Good morning, everyone. My name is Zhang Yu. Today, I will be presenting my research project titled Multiple Factor Stock Selection Using Machine Learning, a case study of the CSI 300 index under the supervision of Dr. Ng Wei Chen. This study explored how machine learning can enhance stock selection strategies in China's capital market by leveraging financial, technical, and microeconomical factors. Traditionally, stock selection has relied heavily on fundamental and technical analysis. However, this method are often subject and may not adjust well to dynamic market conditions. This study addresses those limitations by applying machine learning, which offers a scalable data-driven solution capable of uncovering hidden patterns in large financial datasets. The motivation behind the research is driven by the rapid intelligence of AI in China's financial markets. According to Global Men's Suckers 2025, AI-driven strategies could inject over 200 billion into China's A-share market. Given its trends, it's crucial for quantitative funds and investors to adopt intelligent model to remain competitive. Artificial intelligence is replying transforming China's financial industry. Global Soccer project over 200 million in AI-driven capital inflow to China's share market within the next decade. This shifting pushes quantitative funding to innovate or risk become obsolete. My study is motivation by the trends. I aim to explore how machine learning can be efficiently applied in soccer selection within the CSI 300 index. This study has three main objectives. First, to apply three machine learning models, logical regression, random forest, and XGBoost to predict future stock returns. Second, to construct the backstart profile based on model output and compare them against the CSI 300 index. And three, to use sharp analysis to interpret model decision and enhance transparency, which is often lacked in machine learning models. This research contributes both academically and practically. Academically, it adds to the growth literature on explainable AI in finance, particularly in emerging markets like China. Particularly, it offers investors a transparent, data-driven framework for token selection by combining machine learning with intelligible tools like Sharp. The study brings threats and real-world investor strategies. Previous studies show that machine learning models often outperform traditional stock selection methods. Drewer et al. 2020 and Fisher and Crasher 2018 found ML model like random voice and XGBoost more accurate than classical methods. However, multiple factor model face challenges like the factor zero and overfitting, as not by having at all 2016 to address interpretation. Sharp has become a popular force to explain modern predictors, and discussed by Landy and Lee 2017 and Moliner 2022. My methodology starts with collecting and pre-processing CSI 300 stock level data from two-share and wind. Next feature are engineered from financial ratio, technical, industrial, and microeconomical thinkers. Three models are then selected: logical regression, random forest, and XGBoost. After training and tuning, we evaluated the model and interpreted the best one using Sharp. Price movement, trail variance, Fractal metricals, and technical indicators. We performed four key pre-processing steps. Filter missing data use statistical method. 1. Remove outline using Z-score and IQR. 2. Standardized variables use z-score and min-max securely. 3. Split data into 70% training and 30% tested for field evaluation. Type of features. First, financial metric like PE, ROE, EPS, and W to equal ratio to reflect for fundamentals. Second, technical indicators like moving average, RSI, and boundary brands to capture trend and monitors. Third, microeconomic signals such as GDP growth and interest rate to account for external market force. Within apply reserve feature elimination to select the most predictor feature and reduce noise. We select three models. Logical regressing, serving as a simple industrial rank market. Random forest is rather than handle non-linear relation well. XGBoost Northern for its high accuracy and efficiency is especially good with imbalanced data and complex illustrations. This model will choosing to compare performance and interpretation under the same database and features. Each model was started with spread search. For logical regression, L2 regressionization was with C equal 1. Random forest performance best with 100 traits and dips equal 10. Exposed user learning rate of 0.1 and similar setting develop strong performance and learning future interactions efficiently. Our model will train on 70% of the database and validate using five-fold cross-evaluation. After training, we evaluated the model using four metrics: AUC, F1 score, Sharp ratio, and information coefficient. XGBoost outperformed the other model across all metrics, especially in direction accuracy and risk-adjusted performance. Random Forest ranked second with solid performance but slightly low IC. Logical regression large due to its learning assumptions, which limited its ability to capture complex financial patterns. They use XGBoost prediction to construct a portfolio and rebalance it quantity. The backsetting shows that our model portfolio developed higher return, a better Sharpe ratio, and similar drafts than the CSI 300 index. This suggests that our machine learning strategy not only improves return but also manages risk more efficiently. The portfolio have a model turnover rate of around 25 to 35% per quarter. Keep transaction costs manageable. It was both diversified across sectors, which help reduce risk. The use equal weight and avoid short sale or leverage makes the strategies to impairment for both retail and institutional investors. To explain how XGBoost make decisions we use Sharpe values. The top feature influence stock selection will P/E ratio, RSI, and EPS, all of which are common use by investors. Sharpe help confirm that the model's logical aligns with investor intuition and adding transparency to what would otherwise be a black box model. To summarize the study, building a multiple factor machine learning framework for stock selection uses the CSI 300 index. Among all models, XGBoost performance best in prediction accuracy and portfolio returns. Sharpe analyze improved model transparency by identifying key decision factors. Overall, the framework is not only interpretable but also practically for real-world investing. This study has several limitations. Data quantity issue and model overfitting may affect results, and feature independence assumption may not always hold in real markets. Future work can include sentiment data, real-time of data, and explore deep learning and reinforcement learning methods. Add global marketing data and risk tools like value at risk could future improve the strategies robustness. Thank you for your attention and listening. Thank you for